to the second part of the WOPR build. Today we're going to discuss the BIOS, overclocking, the CPU and memory. We're also going to build a RAID array. We're going to describe what RAID is, and we're going to end up doing a RAID 1+0 installation. Our builder today is Nathan Frost. He is co-chair of the CyberHawks CTF Gaming, and he is our new PC Clinic technician.
Yep.
Nathan, take it away.
Come on, check out the PC Clinic in DTech 235 if you haven't already, if you're a student. We repair computers, do virus removal, and a little bit of data recovery if you lost your files. So let's get started. We need our monitor. This is going to have to be on the other side. Everyone should be able to see that now. And do we have our mouse and keyboard? Actually, we don't need the mouse, but it makes it easier. So today, we're going to go over the BIOS, do a little bit of overclocking, and set up some RAID arrays for hard drives. BIOS stands for Basic Input-Output System, and it's a little tiny chip on your motherboard that pretty much tells it where to find the operating system, how to find the operating system, what to run the CPU at. Thank you. All of that good stuff. You can also set passwords if you want to make sure that nobody can change your BIOS settings. And that's everything. To get to the BIOS, on most home-built computers, you can mash the delete key until it pops up. And what does that say? Yes, this BIOS has been reset so that we start off fresh. And can we zoom in a little bit? This might be a little hard. I might have to switch sides. Yeah, see if I can do this backwards. So let's start out by setting up RAID. And to do that, we have to enable advanced mode. And then scroll down until we have to set the SATA mode to RAID instead of AHCI. So RAID stands for Redundant Array of Inexpensive or Independent Disks. I like inexpensive because cheaper is better. But the idea is to take a bunch of hard drives and make them run in either what's called striping or mirroring, so that they either run faster or you get redundant data in case one fails. RAID 0 is striping. We should have a graphic for that on screen. What they do is they split up the data between two hard drives so that both of them can read and write simultaneously. It's very fast, but very unsafe. If you lose one of your hard drives, everything is gone. Lose all of your data, and if if the drives are still okay, you can rebuild the array, but you won't have any of that data left. RAID 1 is what's called fault tolerant. That means that one of your drives can go bad and you still have your data, which is great for servers, data centers, and the like. But you don't get the speed increase from RAID 0. So all you're doing is creating a backup. As you're writing to one of the drives, it writes to the other one as well. And RAID 5, which is striping with parity. Parity is a way to determine whether or not you have a problem. What it does is it goes and puts one bit at the end of everything to make it either positive or even or odd. And the point of that is, if everything's supposed to be even and you see an odd number, then you know there's a problem and something didn't transmit right. You can also use that with a bunch of fancy logic to rebuild data, which is what RAID 5 is great for. It allows you to get that speed from striping while giving you a little bit of fault tolerance. And now RAID 10, or RAID 1+0, some people call it either one, is striping and mirroring. So what you're doing is you're striping to half of your drives and then mirroring to the other half, which is great for fault tolerance and redundancy, but it requires a very large number of drives. So you'll have half of the capacity of the drives that you put in, which means you would need twice as many drives, but it's faster than RAID 5, faster than RAID 1, and safer than RAID 0. So what we are going to set up is RAID 10, because we have 4 hard drives, and we would like that protection. So let's see if we can find our hard drive section. They always hide it somewhere different. Let's do SATA configuration. SATA mode, change that to RAID. And then this requires a reboot. So we are going to save and exit. And it's a good idea to save profiles when you're all done. That way, if you ever have to reset your BIOS for any reason, or it gets reset when your CMOS battery dies, you still have it on your flash drive. But for now, we're just going to save and reset. Mash delete again. And go back. And now we should see more options. This RAID expert to configuration utility is what we want to click on. Go to array management, create array. Do we not have the option to create the array? Let's check. See, I think there was something that we had to disable in here. CSM support. And then reboot again. And every time you do this, you have to mash delete. Or if you think you're really fast, you can press it once when the screen comes up. There we go. Now we can go to the RAID configuration utility. Or physical disks, that's what we put in. Now let's go to array management, and still can't create our array. There's all 4 of our drives. Let's see if we need to delete an array. old array, which was not an array, is deleted. And our drives are freed up to create one. Now we choose RAID 10 because we want striping and mirroring. And select our disks. Check all. And apply. And now we have our 1 terabyte array because we had 4 500 gigabyte hard drives. And 2 of those are combined together in striping. And 2 are mirrored. Well, there are 2 pairs of 2 striped, and those pairs are mirrored. So let's create our array. And this takes a second. Don't worry if it freezes up for a little longer. It's just creating the array. And we're done. We can go to controller management. And we can see we have our RAID controller and manage array properties. RAID 10 right here. So everything was successful. We have 1 terabyte. And if we wanted, we could start overclocking now. But before we do that, let's save and exit with these settings. Just to make sure everything's confirmed. Now, overclocking is kind of a hard one. There's no set numbers anyone can give you. It doesn't matter what someone else got for their clock frequency, what someone else used for their voltage. You really have to go and tune it for every chip. And we were lucky enough to have someone who used these components previously that knows what they're capable of. So we can go and plug in those numbers. Normally, you would find them experimentally by increasing the clock speed, go into Windows and try out your applications. If it crashes, you bump it back down, or you can increase the voltage. If you go too high on your voltage, you can burn out the CPU, so it's not recommended. And the voltage for the CPU right here is the V-core. 1.2 is where it starts out. Generally, I would not go past 1.25. That's actually really high for V-core. You want to step up in increments of, say, 0.025 volts to find what you're looking for. If you have to go too high, then your CPU is just not capable of the frequency you're looking for. And that's okay. You just didn't win the lottery this time. You could either return it and buy a different CPU, or some people order CPUs in the orders of 10s, 20s, just to find that golden chip. Let's see, what numbers do we have from Kevin? We have the memory, but did he send us the overclocking? Or for the CPU? I have the memory one. Just memory. I'll start out with the memory then. And then we can find the CPU one experimentally if we have to. So for memory, all of that stuff is right in here. Go to advanced memory settings, memory subtimings, and then you get a bunch of acronyms that look very funny and unfamiliar. So CAS latency is column access strobe latency. It's not a strobe anymore, so some people might omit the S in there. It's the time it takes to look up a single column of memory, because memory is arranged in a grid. Then you have the RAS, or row access latency. That's the time it takes to look up a row. And those are the most important ones. As you can see, all of these are normally the same. And then the general rule is you take twice your CAS plus 2, and that's the RAS, and that's normally stable. These are the default timings, so they like to stay a little safer. But we have our own numbers here. We can get 14. CAS. And that would be 30 on our RAS. And now we should only do these. These are the primary timings. These are the secondary timings, and they can get a lot more finicky with the memory. Personally, I would leave them on auto, at least until you can see it boot. So let's save and exit. As you can see, these are our changes that we've made. So we know it wants to change them, and we'll see if it boots up again. And on Ryzen, this makes a huge difference. On Intel, it might not be that big of a performance difference, but you can see benchmark scores jump in the range of 500 to 1,000, and we can see that our computer booted up again, which means at least it's stable enough to post, which is good. Now let's see, we can enable XMP, because that will allow us to overclock our frequency. Right now it's set to 3200. With these settings, we should be able to do 3333, which would be 3333 right here. And let's save and exit. can see our changes again and pray that it posts. And if you're not familiar with post, it is the power on self-test. And it looks like it's trying to boot, but 3333 was not stable, which means we will have to back it off and clear our CMOS. Right. That should clear our CMOS. And unfortunately, we're going to have to go back and rebuild that RAID array. As you can see, everything's back up and running. Tells us that we've reset it. The only way you will damage a computer or a component with overclocking is when you increase the voltage. Since we haven't increased any voltages, even if it crashes, all we have to do is give it a reset and it's back up and running. So we'll enable advanced mode again and go back. Let's enable XMP. And then go back to our subtimings. I've been told that we can get 13 on CAS with 14 on everything else. And then 28 on RAS. So let's save and exit. And even on 3200, it's looking like that is not functional. So let's clear the CMOS. And I'm going to bump that CAS back up to 14. See if we can get it stable that way. Enable XMP again. Set everything to 14. And then 28. Let's see how this does. really does not want low RAS latency. So it looks like we're going to have to loosen it up a tiny bit, go back to 30, and that should still give us a very good performance increase over CAS latency 15. At this point, we could bump up the voltage to try and get it stable, but we did not receive any voltage numbers. So I don't want to push these chips too far. Set this to 30. And that should post. Interesting. Reset the BIOS again. Looks like we're not going to get very far without increasing our voltage a tiny bit. So I'm going to give it a small bump and see if we can get it stable. Oh, sorry, I'll speak a little louder. Oh, I missed the prompt. Restart. And let's see if we can increase that voltage on the memory a little bit. Right now, our memory voltage is 1.212 volts. And just to make sure everything's showing up, we have timing control. Set everything back to where we want it. And 30 on RAS. And go back. To DRAM voltage. And it's nice, Gigabyte gave us some steps we can go to. Right now it's at 1.212. So let's go to 1.220 and see if we can get it stable with that. Nope. So one more step up, and I'm going to call it just because I don't want to damage anything. Normally you could keep going up, probably 2 or 3 more steps if you wanted, but I want to make sure this memory lasts for a while. It is very expensive and very pretty memory that's hard to get nowadays. Change our voltage to 1.23 volts. Looks like it's still not stable at 3200. So we're probably going to have to stick with the factory overclock, which is very good still. Oh, no, I didn't miss it. There we go. Sometimes these AMD motherboards can take a long time to boot up. That's normal. So all we have to do if we want to enable the factory overclock is enable XMP, and you can see our speed changed to 3200 megahertz, and our CAS latency is 14 with RAS at 34 at 1.35 volts. So they were going higher than we were. We could probably bump it up a little bit if we wanted to. But for now, this is an overclock, but the memory came rated for this, so we know it will work every time. If it doesn't, then we can send it back to the manufacturer and get an RMA. So let's save and reset. The XMP doesn't work? Interesting. I didn't reset it this time. Maybe the motherboard just wanted to learn how the memory works. That happens sometimes. We are passing post. And let's check it out. Yep, 3200 megahertz. Pass latency 14. So we'll stick with that for now and move on to, well, actually we can't do the CPU yet until we get our operating system installed and we get some benchmarks on there. So any questions, comments, concerns? Anyone interested in the PC Clinic? Got some old computers to bring in? Check us out. PC Clinic is a wonderful, magical place where you can bring your computer and I will do work on it. Our prices are very reasonable. And we do hardware installation, software installation, data recovery. And you just bring it in. I'll get you set up. You pay for our labor and the cost of your parts. And you leave it with us for a day or two, maybe a week, and then we'll bring it back, and everything's good. You'll have a working computer again. Let's see, what does chat say? Oh yeah, we are not authorized to work on Apple devices, unfortunately, but we can direct you to a couple places that can.
Thank you, Nathan. What we'll end up doing is we'll put an operating system on here, and then we'll put the final readings for the CPU overclocking in the comment section. And if we ever make any more adjustments to the memory timing and voltage, we'll let you know. We'll put it in the comment section. Okay, thank you.
Thank you, everyone. And on that terrible disappointment, it's time to end. Goodbye.